Okay. Let's see if this works. Okay. Okay, cool. I don't know. Yeah, okay. 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 So let me come like this. Go over here. Okay. So working on Vulkan stuff, which is very descriptive, but okay. Okay, cool. So, what are we doing today? What am I doing today? So, I've got 260 about lines of code here, and this goes up until I don't remember what chapter of the Vulkan book. It's like up to wherever surface is mentioned. And I think I'm not 100% sure where that is, but if we go to the Vulkan, I think it's like vulkantutorial.com, I think. Yeah. So if we go there and check, let's see. So this was in the drawing a triangle tutorial. So what I want to do, the goal today is to get a triangle on the screen with this code. That is the goal. But whether or not I actually managed to do that remains to be seen. That we will see. Okay, one sec. Got a lot of... Okay, so I'm up until, I think in this tutorial, is it render pass? I don't remember. So I don't know. I don't think I'm that far. I think I'm right about a presentation where it talks about the window surface. So I think I went through this portion. And like I think I'm here. So if we come over here, I'm pretty sure that's where we got. So yeah, so create device. So my code here is a little bit different. Hello, panders. Okay, my code here is a little bit different than theirs because I'm better. No, I'm just kidding. But as you can see, they have like this create logical device stuff, and then they have this create queue or something, but it's like VK to get device queue, and that's what I did here. And it has, well, this is the present queue. I don't know. I don't think I did the swap chain yet though. There's so much code for this. There's so much code for this. It's horrible. I hate it. I mean, I don't hate it, but I hate it. So I think we're going to start with the swap chain part of this tutorial and just go from there. Which is going to be fun, I guess. But real quick, I'm actually going to... I think it's this. So, by comparison, right, with Vulkan, it takes about 1,000 lines to render just a triangle. And that's it. Like, it's just a triangle, nothing more, you know, which is really a lot of code. But if once this compiles, which will take a second, why does the stream never work the way I want it to here? Yeah, so this is what I have. I've done some code here, and this basically renders a NeoVim window using the RPC API. It doesn't have you can't input or anything. But I got that far. And this is in Rust. The amount of code... do I have Slock installed? I do. So the amount of code for this is... okay, that's actually more than I thought it was. But I actually don't think that's accurate to what... like, a lot of that stuff is just kind of whatever. But if I open this up here, the actual... man, stuff is lagging for me. Gosh. I should probably just not have so many windows open on my other browser here. But yeah, so I have about 360 lines or something, and then with the actual code, with the actual shader code is like 130 lines or something, like this here. And this, which is about 363 lines for the actual rendering portion with Rust and WGPU, that's all it takes to render, to draw text to the screen. So that's like way beyond that's way beyond what the equivalent, like that's, how do I say, I can't speak. So it only takes, less than 1,000 lines by a decent margin in Rust with WGPU to render a lot more than what Vulkan gives you in 1,000 lines, which is just a triangle. Because in this case, I'm rendering like a lot of triangles. I think if I just return, I haven't touched this code in a bit, but if I just do return like a vec4 of like, we'll just do the color red here, and then I run this, you'll see the triangles, like the actual triangles or the squares that I'm actually I'm in the wrong directory. This code is a little not great, but yeah, you can see. Oh right, the middle one is green, so I did green. But you can see each one of these is 2 triangles throughout this entire thing, and I actually like sample from a texture that actually gets the text portion. But if you just disable that, this is how many triangles and stuff I'm rendering in a certain pattern based on the grid of the NeoVim window, if that makes sense. And then like, so, and the amount of code for this is just way less than what Vulkan gives you. But I want to do a GUI elements with the C++ framework Qt, obviously. So, well, not obviously because I haven't said that yet, but that's what I want to do, and I can't do that with without using Vulkan because Rust doesn't really have a C++. It doesn't have like a way to interact with Qt really. That's like not gonna be clunky, and even then I don't think I could use WGPU. So, not the best, but it is what it is. Anyways, so let's get to the Vulkan boilerplates. I should probably turn that noise off. I can increase my mic volume. Okay. This is either better or it's not better. Let me know. I can actually just do like just mic, like that. It's funny because I'm answering, yeah. Okay. So, let's see. Okay. So, I'm just gonna like copy paste this code. I've actually gone through this entire tutorials thing already. Sort of. Like I read through it on my own time and stuff. Whoops. I read through it on my own time, and so hopefully I don't have to like read all this text and stuff, because that makes this so much longer than just looking at the code. But yeah, anyways. So I don't think I got as far as device extensions. I did not. So we're just gonna, I'm not sure how I feel about the whole like, I'm not sure how I feel about all this stuff. Like creating a vector like this is kind of I'm not sure how I feel about it, but we'll do it because it's fine. Actually, didn't I like... No, I don't think... Okay, that's fine. So, this is for like checking swap chain support and stuff. So, I'll just put it at the top here. And then, is device suitable? So with Vulkan, obviously, you have to like choose the device that you're gonna use, which is like GPU, and so you have to like choose that, and then I think I might actually move this down here. I don't know. There's not a good place of putting any of this code, honestly. Well, it'd be nice to put it where that's actually defined. So, so it's down here. So we'll just put it closer to like. We'll just put it after create surface. That's fine. So basically, do I not have a find key families thing? I thought. Oh, is that like a built-in? Right. Okay, this is. Wait a minute. Find queue families is a function of. Oh, can I just like not what? Oh, it's it. Oh, because I did this differently. This takes the surface and the thing, which I did not do. Because they did it. I don't know why I did things differently, honestly. There's probably no reason for me to do that, but it's fine. So we can just change this to take a, what is it? We can just make it take this. The problem is the actual Vulkan, like the code they make you write in this is not the greatest. Like it's not perfect. So I just kind of like do my own thing a bit, cause like I don't know. I'm not a fan of the way they do everything, so I don't have that function yet. So this is check device extension support, and then we extend it. Okay. And this is gonna take a, because I think I feel like is the surface mentioned in this? Because if it is, then like, no, it's not. Okay. Address device. I don't really need to do no accept, but we're gonna do it anyways. And then basically we're enumerating the extensions and checking if they're so. With Vulkan, obviously, to like display different things or whatever, you have what are called extensions. And so like Vulkan is so low level that the basic extensions that it comes with, like if you don't modify any of this stuff, it doesn't even, like you can't even draw to the screen. Like that's an extension. So it's very bare bones, and that's on purpose, but it's just, it's like, it makes for, you know, actually writing the code to take a lot longer. But the funny thing is that apparently this code exists on GitHub because Copilot knows what we're doing. Let's see if it can do the right code here. Yep, that is correct. I'm guessing that's also correct. Yep, that's fun. Copilot makes this easier. Okay, so then we'll just grab this. And I'm not a fan of std set really, but it's probably fine. Because like std set is kind of just like not performant compared to other stuff, but it's fine. Just because like, I mean, in the broad scheme of things, especially when you're talking about rendering and stuff, like using std set here for like barely doing anything is not going to make much of a difference, I don't think. But I still don't like it. Where am I going? Okay. So then basically what we do is just do this little loop, which is fairly straightforward. And we're just saying, hey, all these required extensions that we need, we're just asking Vulkan, hey, what extensions do we need? And then we're going to iterate over those. We're going to put them into a set, and we're going to iterate over them and erase them one by one. And then if it's empty, that means that we found them all, and we're good. So that is allowing us to check the support for the device. And then enabling device extensions. Let's see. creates info. I missed something. Oh gosh. Gosh. How do I can I ban people? Gosh. I don't know YouTube how to ban people. Gosh. Okay, well there's can you even ban people? I don't know. Oh gosh. Okay, anyways, we're gonna ignore that. So we have like create info. Let's see. So create info. Where is this? Using a swap chain requires enabling the VKKHR swap chain extension first. Enabling the extension just requires a small change to the logical device creation structure. So logical device, create logical, wait. VK logic. Oh, I guess, well, it's just like, okay. The logical device is just VK device, which is interesting, but this is fine. So, device extensions. How do we modify this exactly? So, create info to enabled extensions count is just device extensions. So, device extensions, which is this, the required extensions, which we then. What? I don't, but device extensions isn't created here. Or wait. Oh, duh. Oh, never mind. Now I look stupid. Okay. Gosh. So this is the VK instance create info, which is not what we're changing. The VK device create info is what we're changing. So instead of enabled extension count equals 0, we're going to say it's equal to this. Oh, gosh. I keep doing that. Why do they have the lookup button above the copy button like that? That's very annoying. Okay. Well, how do you do this with both validation layers and... Oh, no, that's layer count. Okay, that's different. That's different. Okay. Cool. So now we have our enabled extension and our enabled extension names. And so one thing that's actually kind of interesting is if we go to our device extensions up here, you see we use this macro. And if we actually go to definition here, it's literally just defined to a string. The reason that you use that instead of just doing VKKHR swap chain like this is for type safety or whatever. So like if I make a spelling mistake, this actually won't compile versus this will compile. So that's all that's done for. It's longer, but it makes it more safe kind of. So, but of course we don't do that here. I don't know why. Do they actually have VK layer Chronos validation? Is that actually like a macro here? No, it's not. Okay, so this isn't deserving of type safety, but I mean we can make our own type safety. I'm just kidding. Okay. So there we go. So we've done that. We have done that now. So struct swap chain support details. So again, all this stuff that is abstracted away and things you have to deal with in Vulkan, which makes this not fun, but it's fine. So we'll just put this struct above our render function, I guess. So just do this here. And I could actually make this a class, but I don't really care. I mean, I can make it a class. The difference between a class, it's funny, the difference between a class and a struct, well, that I just confused myself. The only difference in this case versus this case, like if I do this and I do this, I don't know why I'm doing this because you'll probably know this, but if I do this, then They're the same thing. They're equivalents. Because a class literally just is a struct, but it makes everything public by default in C++. In C, this is not the case, obviously, but in C++ it is. So why even have the class keyword? I don't know, because it sounds cool. It's more object-oriented or something. Okay. I can make this a static function? Maybe? Should I make it a static? Maybe not. I could make it a static. Is the music even audible right now? I don't think it was. I don't know. I had it. Okay, now it is. Huh. Anyways. Okay. Let's do like this. Ah. Okay. So let's go here. Oh wait, I already did that. Okay. So we're basically going to get the physical device capabilities. And I think all this stuff goes in here. I really don't understand why they keep passing this by value, which is weird to me, but also they don't take a lot of these. I think they just have defined on like the actual struct, which doesn't make sense to me. Compared to like, I don't know why they do that, because it's just not like the best code in my opinion, because gosh, trying to manage all these windows is really annoying in macOS. But yeah, I don't like the way they do things at all times. I really need to enforce a consistent style here. Okay. So like they don't take any of this stuff by like const ref. I don't know if that actually makes a difference. I mean, for all I know, it could just mean that like none of this works, but I hope not. Although I guess I could be wrong, but we'll hope. So now we query the formats. Again, generally speaking, these are all done in the same kind of way, where you basically first pass in a null pointer, and then you resize your thing, and then, you know, it's just like, it's all this annoying stuff. It's really annoying, but I should probably write this out like by hand, but I really don't want to, so I don't think I'm going to. So this gives us our present modes. Details. Oh yeah, so this is just we're just filling out our swap chain support details. Which in theory, I mean, we could in theory put this as like a constructor or something, but I'm not gonna do that, I don't think. So now we're going to extend our isDeviceSuitable function to then use this stuff. So we have our extensions supported. Like that. And then obviously we need to pass in the surface because it uses the surface, and I'm doing this all as a sort of like whatever. Okay. So now we have this isDeviceSuitable function. Where? Okay, so we finally do this when we create the swap chain. Okay. Is device suitable? Is this never called? Because that would be funny. I mean, I think it's called, but that would be funny if it wasn't. Anyways. So now, time to get our swap chain surface format thing. And we're checking for our preferred combination. And then if we don't get that, it's okay to just settle with the first format, which is fun. Oh, okay, it's returning available formats at 0. It'd be funny if this was just like fails in real life, like I run this program and this just like fails or something. It's like there is no available formats. I could see Vulkan having some situation where that's not exceptional and you have to handle it somehow or something, but yeah, all this stuff is annoying. So this actually gives you information about what each of these present modes do, which is interesting. So like if, why is the function definition not allowed here? What? What? I can't type. What? What am I missing? Why can't I define a function? What? I am confused. This part of the file is cursed? I have no idea. Anyways, so we basically have these available present mode, and so if it has this one, then we'll do that, otherwise we'll do this. So, present mode mailbox. Is a very nice trade-off if energy usage is not a concern. I mean, I think it kind of is a concern, but what we'll do is I'll just like throw it to do here. I'll be like, think about this more or something. I don't know. So that's just like a to do, because this stuff is or something. Is it present to? Yeah. I'll just put that there, so I know to come back to it if I need to, or if I want to. Okay. So now we're going to choose the swap extent. Let's see if we can actually define a function here now. That's not. Capabilities. Okay, jar. Apparently I can't spell. See, sometimes it takes it by const reference, but other times it doesn't. I don't understand. Why is it not want me to define a function here? I don't understand. What? This makes no sense. Wait, int main? What? I am so confused. It doesn't... What? I feel like there's something I'm missing, but I don't understand what that is. Did I like to find a struct and not put like the semicolon at the end or something? But why would that only make it go here? And why is this function valid and this one isn't? Can I do like, if I had a return statement, does that fix it? What is the return null pointer? No, I don't understand. See, that's the thing. I don't think it's extra brackets, because like if it was extra brackets, then this would still be invalid, because I'd have like an extra bracket here or something, which it wouldn't be okay with. But for some reason, this I don't understand. Because like, look, if I put this here, it's fine, and then it just like has this type check. It's a cursed portion of the file. I don't know. It's extremely confusing to me. But oh well. I'll just worry about it when it actually becomes like a real problem, maybe, because right now it's not really a problem. I guess we'll throw these includes in here. C stood int. Okay, this is funny. This isn't even right. Like C stood. Why would you don't? Well, I don't need that because you can just do student.h. Or maybe it is. Maybe that's the right way of doing it. I don't know. Limits, stood numeric limits, and then algorithm for stood clamp. Okay. Okay. So now. So choose swap extent. So, you know, I'm actually, I think maybe gonna write this out because I kind of want to like go through it a bit. Well, I might not write it all out. So basically, what we're doing here is capabilities.currentExtent.width does not equal stood numeric limits max. So I guess this checks. All right. So what ends up happening is if I think it sets it to infinite if it's whatever. So like if it has an extent, I don't know. Basically this is just telling Vulkan, hey, what's the window width and stuff? And it's like, this is what it is. So because you literally have to tell Vulkan how wide your window is, which is really annoying. Because unlike in I think WGPU, this is kind of just like handled. Or well, maybe it isn't actually. I thought it was handled. Maybe it's not. But in Vulkan, it obviously isn't, because Vulkan is just like everything. Vulkan is like everything. Everything is annoying in Vulkan. It's not exactly true, but anyways, GLFW window, pointer window. And I think we can make this a const pointer, because I don't think we need, nope. We need an actual window pointer. Because apparently this changes the size of the window in GLFW. I don't understand, but it's fine. Okay. So then this actually clamps the width and height between the allowed minimum and maximum extents that are supported by the implementation. Which is fun. Okay. So now we can actually create the swap chain. Render down here. So this is one interesting thing I've done. So normally these are actually functions that are defined within the actual renderer struct, but what I've been doing is just putting them outside, like create devices up here and stuff. Whether or not that's actually a good idea remains to be seen, but I feel like it's better because if you can make it just functions instead of the object-oriented stuff, like, why not? And I would define the function here, but apparently I can't do that. So we'll try, but I don't think it'll work. Create swap chain. Is that? Yeah, okay, that's fine. Yeah, look. Why does it do that? What? What? I am so confused. Does that happen if I do it like this or something? No. What is happening that this happens? I'm so confused. What? I do not understand that error. That makes no sense. Oh, it's saying to match. Does it? I don't understand. It's like it doesn't like this. But that's not it. I do not understand. I mean, I feel like it has something to do with these macros or something. Does it? Oh my gosh, duh. That was a bug. Now it should build. Oh my gosh. Why is C++ like this? So apparently, this is valid code. Or well, what was it like? It was like this. So it was, the for loop was closing down here, and somehow that wasn't completely broken. Wow. It's stuff like that that makes me prefer Rust over C++, because that would never work in Rust. I don't know. Whatever. Okay. Well, there's that mystery solved. Okay. Cool. So we queried the swap chain support. I don't know if this will actually work. So we query the swap chain support, and then surface format, and then we choose the swap extent, and we do all that stuff and everything else. But what is the one that takes the GLFW window? I don't create, wait, no. Choose swap extent. There we go. So create swap chain, which actually needs to be, well, we can do it like this. Why is that not actually causing an error? Oh, it is. Okay, good. Okay. Let's see, device. Well, physical device. There we go. And there we go. So now, CCLS is pretty terrible. I might have to switch to something less terrible. I need the surface as well. Okay. Does this build? It does. Cool. And so we need the swap chain. I'm gonna go ahead and add this actually. Well, actually, this is gonna be created in here. So okay. So time to actually create the swap chain. Aside from these properties, we have to decide how many images we will allow. However, simply sticking to the minimum. So it's recommended to request at least one more image than the minimum. So we'll do that. Oh look, Copilot being nice and helpful. I wonder if it'll do the actual if swap chain. So if the max image count is greater than 0 and So we can't exceed the maximum, but there is no maximum. So if it's greater than 0 and the image count is greater than swap chain support capabilities to max image count, then we're just, so like if the images we're trying to get is bigger than the maximum we can have, we'll just set it to the maximum. So that just makes things a little bit nicer, easier to read. I mean, not exactly, but I'll do it like that because it's fine. Okay, so vk create info equals. Now, what I generally like to do is actually define these myself, like define them in here because it makes things cleaner. Not like that. Copilot, you're not helpful. I mean, sometimes you're helpful, but not usually. Or well, sometimes it depends. See, okay, this is something about Vulkan I really want to understand. Why do you have to do this? I really actually do not know, but it kind of irks me because I don't understand why you have to do this. Because the struct type is as if it tells you the type it is. Like, it's literally, this is the type. So why do I have to tell it that this is the VK structure type? Like, does it erase type checking at some point or something? Like, why? Like, I don't understand. I mean, if it's like some weird C generic thing that I don't know, like if, I guess it could make sense if it was like a void pointer and you could always depend, like if internally it uses a void pointer somewhere and then you could always assume that S type is actually defined and that would tell you what the structure is, maybe? But that's the only reason I feel like that would be necessary. And I don't know if that's why or not. But it's kind of annoying. Because it's like the type's right here. Like, this is the type. Like, why do I have to define it here? Okay. So we want to set the surface to the surface. And then the details of the swap chain images. So we'll just put this in here. Using good old nice little things here. Okay. Oh yeah, this is actually, well, wait, does it use commas or not? I don't remember. Oh, you can define it like that. Okay. This might not even build, actually. Yeah, it doesn't. It is commas. Okay. I was wondering why it did like the way things were there. Cool. I actually don't know if it allows trailing commas. Does it allow trailing commas? See, the annoying thing with C++ is that, like, this could be undefined, like I've seen stuff that, like, the order of these has to be the order they were defined in the actual struct. And it seems like that's not actually the case. Like, I feel like if I do, like, this, like, it'll still work. Like, it still compiles, right? Like, this will still compile. But I have no idea if this is undefined behavior compared to this. And C++, like, you have to find that in some obscure version in the reference, in some obscure place in the reference or something. And it's so annoying because, like, in Rust, if that was undefined behavior or if it wasn't allowed, like, it would tell you, like, almost certainly. You're not going to have that foot gun. But in C++, who knows? I have no idea. It could totally have that foot gun, and it just, like, wouldn't tell you, and then it'd, like, break, and you just wouldn't expect it, and then, which is just so annoying. Okay, so this is for post-processing stuff, I think, or, well, it's related to it. Image. You'll render images to a separate image first to perform operations like post-processing, which I actually probably am going to do in the future because I want to do something with text, with the text editor that would use post-processing, which would be Bloom. But we'll keep it simple for now. Which, like, I'm going to copy this text and put it in here or something. Just as a note, so I remember. Okay. So now we will copy this in here. So this is just telling us things like sharing mode exclusive and da 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 da, whatever. So we'll be drawing on the images. So there are two ways you can do exclusive. And because you need concurrent if the graphics family and the present family aren't the same. This stuff is so annoying. It's like this stuff is fine, but it's just so much boilerplate. I mean, like what are we at right now? I mean, I should just like keep writing code and not worry about it. But we're at 410 lines of code, and we're still not even close to having a triangle on the screen, and that's just like discouraging at times. Anyways, so we'll just like copy paste this because we need the pre-transform to be the current transform because we're just not transforming anything. Because you can like turn it 90 degrees or something, which is interesting. I mean, it's cool the kind of stuff you can do with it, but it's like, I mean, heck, you can change the composite alpha blending stuff. I actually probably might want to change this. So we'll just go like that. Okay. So present mode. We want the present mode to be the present mode. And the clips and the old swap chain is there. So this is going to actually be, this will be relevant with swap chain recreation, I think, because you specify the old swap chain, which is just done. It's specified for some reason, maybe performance. I don't know. Vulkan wants you to specify it, but in this case, we don't have a swap chain yet, so there is no old swap chain. And now we can finally create the swap chain, which makes me happy. So, over here. So, well, actually, it's up here. So, VK swap chain, KHR swap chain. Have I been throw? Yeah, I don't think I haven't used throw once in here. And the reason, I think I actually have used abort or something. I don't remember. But I haven't. If VK create, yeah, I've just done this. Just because I don't like exceptions. And if I care about this, when I care about these errors in the future or something, I'll probably actually use something like boost outcome or something like this, which is supposed to be in the standards. Like people want that in the standard lib or something. Why can't? Really? Okay. Well, whatever. But yeah, that's something that is for the future. I'm not worried about it right now. VK swap chain KHR. Is it VK swap? No, it is lowercase. Okay, that's interesting. If VK create swap chain, where is it? Swap chain KHR. Device address of create info null pointer, because I think this is for allocator, and then address of swap chain does not equal VK success. We want to stud Sierra. Your mom. I'm just kidding. Failed to create the swap chain. And then exit of exit failure. Okay, so now the parameters. Now it's gonna say at this point if you get an access violation error in VK or same message, if you get this, but I don't. I hopefully don't. So I want to see if the validation layers work, which they should. I also hope this all builds and runs and works fine. So we have another now we have another thing to add to our continually enlarging list of things. Is it the physical device that we need to pass it? That's a lot of function. It is the physical device. Okay. Like it as well. Okay, so now I don't know. Let's see if it builds. It should build. It doesn't build. Find. Wait. Is that in create swap chain that we have a problem? Yes. That's a long function. Oh my gosh. Find queue families. What do we have to pass here? The surface. Which I think is available. Device. Oh, it's physical device. Yep, it's physical device that we use. Okay. Or we call it physical device. I call it physical device. They call it device because reasons, but I don't know. Oh, it needs a non-const ref, I think. Oh, I have a void function there. That's part of the problem. It needs a non-const. Oh, it needs a pointer? What? Okay, I'll worry about that in a second. What is the other thing it wants? Oh wait. Wait, physical well, I'll worry about that in a second. So it actually doesn't even. I don't even have VK create swap chain KH. I'll worry about that in a second. Volt create swap chain. There we go. There's that done. So now the question becomes VK swap chain KHR, VK swap chain. Oh, I spelled it wrong. That lowercase versus uppercase C is annoying. So this function doesn't exist for some reason, and the other thing. Oh, it's no match. So this function does exist, but it just can't. So it's trying to convert VK physical device. Oh, it wants like an actual device. It doesn't want the physical device. Gotcha. It wants the device. And does it need a non-constant reference? Oh, we need both. Okay. Well, fine. That feels wrong, but we'll go with it. Does it build now? It does not. Const, yeah, so it needs a non-const, which makes sense. I wouldn't really expect it to need const. I would expect it to be non-const, but yeah. Or wait, no, it wants a non-const physical device. Or wait, I'm passing the physical device. Oh gosh. I can't type things. Okay. Now let's try. Yay! Okay, it builds. I feel like if we run this now, so we're not actually cleaning up the swap chain, and I feel like that should be cause for. Oh, okay. Good to know. Well, thank you. Wow, macOS, you're so helpful. Okay, we'll worry about that in a second. It should be cleaned up before the device. VK destroy swap chain KHR. Device swap chain null pointer. We need to destroy the null pointer. Okay. So so why is it crashing? This is the fun part. Get some, yep, we're gonna have to debug some stuff. Awesome. Oh gosh. Okay. Oh wow. It's trying to read empty memory. How very, very helpful. You know, that's extremely helpful. I mean, like, this is so useful. Look at it. I mean, it's unbelievably useful. So, something's happening in create swap chain that it doesn't like, which is not very helpful, but it's fine. It does not like something. Something's null pointer that shouldn't be null pointer. We'll just see. None of this stuff can like really be. I actually don't think it'll even log this because, oh well, maybe it will. C++ logging is terrible if you didn't know that. So whereas in Rust, I could just do print line like this, and then I could put this little magical thing here, and I could do window or whatever, and it would print something actually readable. C++ doesn't have that, so I have to suffer, and it's awesome. But this should tell me what's going on here, maybe, potentially. Or it won't, and I'll be confused, which is also possible. And probably likely. Okay, so none of those are null. Awesome. So none of those are null, which gives me every little bit of understanding. Okay. So, did I get these arguments right? So it wants the device, and it wants the swap chain, and those should not be const. I can't imagine. This is the problem with making stuff const when like you have no idea. Like I have no clue what the problem is here. And when you're interrupting with like C and everything else, right? So this is allocation callbacks. I don't have an allocator, so this is not a problem. But this is failing for some reason. So one way of figuring this out is to do this, or that's one way I'll try this. Doing the nice little print style debugging. Okay, so the problem is definitely for sure the and then it crashes at the end there because I'm trying to delete the swap chain when it's null, but it's trying to create the swap chain and that's failing. So we know that much, which is useful. Why is it failing is the question. Is it's trying to do the VK create swap chain KHR, and it can't. So I'm wondering why it's actually failing here. That's actually a good question. I don't know why it's failing. Because none of this stuff is null. I mean, obviously the swap chain is null, but it's supposed to be. So... obviously the device is a non-const reference. And over here, we pass it in like that. So that's being passed in correctly. And we pass in the window, we pass in the surface. Obviously the surface, all this stuff works. It queries the swap chain support. And then it fails on the creating the swap chain call. I'm not sure. Ugh. See, it's just, I'm not even kidding. This stuff might push me to Rust. Because I can't. I hate debugging seg faults. I hate it. I hate it so much. So much. Okay. So much. Because what this tells me nothing. It tells me nothing about what even happens. And now my thing's like freezing. Like, what is happening? Like that's so not useful. Like, what? Come on, man. Ugh. I don't know. What is happening? So I'm calling the function properly. That's not the problem. And it's not a problem with create info, because like if it was a problem with create info, then like it would say something. At least we'll see. Time to go to Google. And we shall see if that actually helps. macOS. macOS. Failing macOS, maybe. Why is it failing? What? What? Okay, if this... If this... I'm not... If this... I swear. If this... There's no way this is gonna make a difference. No way. Zero. There's zero way this makes... There's no way. Okay, it didn't. What? I don't understand. Because I did the GLFW no API, right? Because you have to give this window hint. Otherwise, Vulkan doesn't work. But that doesn't make any sense why everything else up until this point, up until the swap chain creation, would work. And then this doesn't. That makes zero sense to me. It doesn't even fail with like an error. Like it just fails. It just seg faults. This is why I hate Vulkan in some ways. Like why? Like why does this fail? Let's do like seg fault. See, it doesn't even fail with like a poor VK result or something. Oh wait, maybe it does. You know what? It might actually fail like that. No? What? Wait. Well, that doesn't even count. Okay, that wouldn't count as a seg fault. So this isn't gonna change anything. It literally segfaults on the actual call, which makes 0 sense to me. And it's not this. Like, this is not going to make a difference. In fact, this would probably not compile. Yeah. Like, and I have, like, Vulkan. Yeah, like, it has to have Vulkan. Like, it has Vulkan installed, right? Actually, maybe it doesn't. One sec. That's actually... I don't think this will change anything, but we will make sure that it doesn't. So, and it has to build GLFW from source because I like building things from source. Don't judge me. Or something. But okay. See, it still segfaults, and there's no way of knowing why it segfaults. Like, what? I don't understand. See, this wouldn't happen in Rust, man. I mean, I know people, whatever, the Rust evangelism people give Rust a bad name. But this is not helpful. Like, what is the error? Programming, man, it's wonderful, isn't it? Why? Why? It's like the create info is fine. Like, what's wrong with the create info, man? There's... I don't understand. Well, I'm lost. Let's see if Rust can let's see if I can just do this stuff in Rust. I mean, honestly, I am so tempted. Okay, check this out. Okay, so I'm actually really tempted to try this in the future, and I might actually, I might actually do this. So obviously I maintain Revonum. Well, I haven't really done much with it recently, but so the Revonum, I actually have a PR that I was working on. This I need to merge these, but it was removing Electron via Tori, which is cool, and people think that's cool. But the thing is the text rendering was terrible, and trying to get that to work well is kind of annoying. But if you can you can actually read the fonts using like FontKit. So like text rendering is the bane of my existence, by the way. Just gonna throw that out there. But with FontKit, you can basically, create something that's like you can query for what am I trying to say? You can query the TTF file from the system. Like I want this, like, where can I find the XYZ font that the user's asking me for? And then it will give you the path to that font. And so anyways, you can basically use this with Tori to then send that to the front end and then use that font for Skia. But Rust Skia didn't actually have bindings. It wouldn't work in WASM until recently, where they merged this. And now WebAssembly support exists. So now that it has the ability to compile to WebAssembly, it's very, very nice. So, and if we look at fonts, if I search font, you can see that we can actually create fonts. So what I might do later, I'm not doing it right now. I'm probably actually going to take a break from programming and end the stream. But what I want to do is, I think I still have on my computer. Here's the thing, okay? Skia supports shaders, right? If I search shader, it supports shaders, okay? And if we go to Skia's website, not Skia's, Skia programming, because I'm sure other things exist. But if we go to Skia, you can see that Skia actually supports, I don't know if it supports post-processing, like, which might be kind of actually it might not. It might not be totally SK image filter. Skia's docs are horrible, by the way. I just want to throw that out there. Yeah, okay, that's cool. See their docs. Ugh, oh my gosh. Trying to understand Skia is really annoying sometimes. But if we look, so Skia can do stuff with shaders a lot. Like, it definitely can. So I don't know. Let me search shader. You definitely have shader things and stuff. So like SKSL, right? So it's Skia's shading language. And if we look, we can see that we can do this stuff, right? So we can have our image, and we can do really cool things with that. So obviously we can like do BGRA, then swap red and blue, right? Whatever. And so we can essentially use shaders. So because of this, right, you can still have all the niceties of using shaders and using all that stuff, and you get GPU rendering, but you get GPU accelerated rendering through WebGL, and Skia is pretty quick. But you can render text sanely, and you don't have to deal with what I'm trying to do with, which is use MSTFs and stuff. Now, granted, I don't want to do this because I really want to. I really want to go down the MSTF route. But not only is it kind of over my head, it's probably unnecessary for a text editor. In a world where there are text editors like, VS Code, which is like an Electron. I mean, heck, Uivonum is an Electron, although Uivonum uses WebGL for the rendering. It's a cool idea, but I just don't know if I can pull it off just with the way things are. I might still do it for a proof of concept. Like, I might still work on this, because this is just a really cool proof of well, let me let me fix that real quick, which is in shader.wigzle. I like saying wigzle. It's fun. That's what the wigzle. Anyways. Like, this is a really cool proof of concept that I'm kind of proud of. Like, just that it's just cool. I thought it was. I keep forgetting you have to run this from the root of the directory. Anyways, so this is just cool, and it renders text fine, and it's a little choppy, but it could be improved. The problem is when you try and render more complicated text, and when you get into more things, it's possible to use this. It's just hard. And I feel like Skia, I mean, there's a lot of stuff that uses, I mean, Neovide uses Skia, and Neovide runs great. So I'll probably go that route, because I'm very quickly losing motivation on trying to get this, just because I'm really kind of disappointed with the way the ecosystem and stuff exists. And trying to use Vulkan is just a recipe for disaster. I could use OpenGL, but I don't like OpenGL's API, so... because I'm spoiled with WGPU. It's just very, very nice to use. And as you can see, I was able to actually get something working. So I might still go the rewrite MSTF gen, MSTF Atlas gen, whatever, in Rust, and then still make a GUI like this and just use eGUI for the elements, and it won't look native or whatever. It's not like the best thing ever, but it could work, because eGUI doesn't look terrible. It could work. But as far as like getting something that has like the eye candy stuff and that looks really good, I will probably not do Qt and everything else. I'll probably use I'll look into using Tori, I think, maybe. That's the plan, because I'm annoyed with Vulkan, with this VK swap chain. I don't even know why the swap chain doesn't work. I know it's kind of weird to abandon all this stuff just based on this, but like I have no idea why this doesn't work, and it's kind of like, trying to use Vulkan is just, it's very annoying. The weird thing is that I think if I like Vulkan works on my system, so I don't understand why this doesn't work. Because we have the physical device. We create this device. As a last ditch effort though, I'm gonna actually do the setting up of the debug manager. I never did that, and I probably should, because I think that's what allows the I think that's what actually allows this stuff to work. So yeah. So I'm just gonna run through this real quick, and we'll see if it fixes, or if I can actually like get a reason why it's failing. And then if I can't, then I can maybe just like worry about that later. So get required instance extensions. Yeah, so here, which is where we actually do the create instance, right? And we say extensions, and then we enable the extension count and all that stuff. We're gonna actually create this guy. So it'll return a list of extensions. So we're just gonna say std vector const char. We're going to get the instance extensions, and then we're going to actually create the extensions, and then we're going to say extensions.pushback the vkxt debug utils blah 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 stuff. And then down here we can just say auto extensions, get required extensions, and then enabled extension count is going to be our x count here. So we'll just grab this guy, and then the enabled extension name is extensions.data. And enabled layer count can, I guess, just say the same? Maybe. Okay, so now let's see what a debug callback blah 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 thing. Just create this insane looking function. It's very fun looking at that beautiful function definition here. And there we go. So I don't actually know what it's returning. I'm just gonna log everything. And then in renderer, we can just create our vkdebug utils message messenger ext debug messenger, and then in inits we will say setup messenger okay. Enable validation layers. Okay, and then we'll need to fill a struct about, of course you have to fill a create info about even the simplest things. Why is this so long? Oh my gosh. So it's just telling me a bunch of stuff that I don't really care to read. So the struct, we're going to create our own proxy function that handles this in the background. The vk debug utils messenger x objects. Okay, well, whatever. I'm just gonna define this up here. I don't even really care about the code that's in here. But I mean, it's not that big a deal. But it's not that hard. But it's fine. Okay. So, if create debug utils messenger ext. Watch this cause a seg fault. Does this build if you have no accept? I feel like it wouldn't let you throw. See right there. Call back. Call back. I don't know. Call back. Call him. Okay. Instance create info debug messenger. Oh, it would lose const qualifier. Const vk debug utils messenger ext. What is the constant? What's constant here? It's I see. It's actually modifying these, so we can't do a const. That is a horrible error. So if I have const here, I get an error down here, and it doesn't even mention const at all. Like, it doesn't mention, oh, there's this const. Maybe, like, maybe you should remove it, right? Like, no, it's just no matching function because it would lose the const qualifier. It's horrible. Horrible error. Okay, so that builds. Good. I think we actually need to create the instance before we set up the debug manager, which is fine. Because it seems like that's the case, because we actually passed in the instance here, so I assume that's what has to happen. And then we will create another proxy function, which I could probably put this at the top of the file more, but I don't really care at this point. And then in cleanup, if enable validation layers, we will do this and before we destroy the instance, I guess. We can then call it in the cleanup function. Cool. Sounds good. So, although we're not covering everything quite yet. It requires a valid instance to have been created, and vk create destroy debug must be called before this currently is unable to debugging. I don't care enough to do that, I don't think. Because we're not debugging the instance creation stuff, but I'm not too worried about that. Okay, let's see if we get debug. There we go. We have some debug information here. But none of this... None of it helps. None of it helps. How wonderful. Isn't that amazing? Look at it. It's beautiful. We can set this up, why not? Populate debug messenger create info. However, if you closely read the extension, you'll see it requires you simply pass a pointer to vk debug utils create info next extract in the first extraction. Messenger create info. Destroy. Whoops. Wrong thing. Okay, part of this is we're logging everything. Maybe we shouldn't do that. Debug messenger. Where did I put that function? I don't even remember. Debug callback. Okay. I'm gonna actually move this. So, validation layer, whatever. So, that's not something here. So, if message severity, right? Right. Right, message is important enough to show. And then we'll just say p callback data. P message, like that. And now we should only get the ones that are relevant to what we're doing. And we get nothing. How wonderful. What happens if we just don't destroy the device or something? I don't know. Like, why don't we get any warnings? Set up. GLFW, destroy window. Variables placed outside the if statement issue is not destroyed before the VK created. So this should be cool. Whoops. See, it's just this stuff that's just so annoying. Like, set up debug messenger, right? Like, we do that. And obviously the validation layers are not disabled, but if we have, like, std_cr, none of this is happening, right? And I don't think it's failing at this. I can test it fairly easily, I guess. But it's so annoying. See, look, it's just failing at the swap chain creation, and I have no idea why. Because, like, it's failing there, and it's just doing that for no reason. It's failing to create the swap chain. VKKHR swap chain to the device extensions at VK device create info. Oh. Are you kidding me? Are you kidding me right now? Are you serious? Don't tell me. Don't. Oh, gosh. Oh, my gosh. Dude. Come on. I was actually ready to give up on this. Dude. Oh, my gosh. I found the problem. This was the problem. That was the problem, and there was nothing. There's no errors. There's nothing to tell me that. Nothing. Zero. Literally nothing. Like, seriously? Ugh. Come on, man. So, this is what I'm talking about with Vulkan, okay? If something like this had happened in, I don't know, heck, even in Molten, like, was it Ash or something? I think it's called Ash. Is the Rust, like the Rust Vulkan thing? Yeah, the Vulkan bindings for Rust here, right? These, whatever, right? But it was just literally the issue here. If I had done something like this and I'd forgotten it I had forgotten to enable the validation layer that actually allows you to create the swap chain, which is what I had done here accidentally. If I had done this with Ash or something, I'm sure that Rust would have because, I mean, granted, this is kind of a Vulkan problem. This isn't really a Rust problem, or this isn't really a C++ problem. But the fact that literally one line can cause so much headache is just, it's horrible. It's horrible. It's really horrible. And I guess this is true of pretty much any graphics framework. But man, that was rough. That was rough. And there was nothing to even tell me that. Like, the validation layers don't even catch that error? That's just crazy. That's crazy. Well, there's that problem solved. Okay, cool. I can continue now. Gosh. Man. Why? Why is that a thing? Okay. So I want to see if this validation layer there is so called with there. So try moving the create info image extent. Let's see if we remove that, and let's see if the validation layer actually catches this. Hey. I think it actually caught it. Whoops. It's not the best error ever. What? Wait, what? Why does that not catch it? This doesn't actually catch this. Is not equal to the... Is it because of how I'm logging this? Ignoring invalid set drawable size. I mean, so it's logging it anyways, but interestingly, it doesn't seem to be related to what I'm doing at all here, which is kind of annoying. Because like if I just disable this entirely, yeah, it still does it. It's interesting. But okay. Well, at least it kind of tells me something. I don't know. What happens if I do this? Invalid pixel format. Yeah, so it's like invalid swap chain. Yeah, the errors are just bad, but it is what it is. But okay, let's do this a bit. We'll just do struct renderer, and then std vector. Once we have the swap chain, we can then do. So okay. Wait a second. So I'm adding the code to retrieve that right after the VK create swap chain call. Okay. So, I mean, we could return like a tuple or something, but let's just make the create swap chain function a member function. Even though, I mean, like, it's not the best thing ever, but it's fine. This way, we actually don't need we don't need like any of this stuff, I don't think. Well, we do need the like that, but this should all be there. So we can then just say swap chain equals swap chain. And then we can just create this here. Cool. Why does that not? Oh, is that just because we create the swap chain or whatever? Like, is it really this that's doing that? So it creates the swap chain, but oh. There we go. Ignore. I actually know what that segfault's about, but it's probably fine. There you go. One last thing, store the formats and extent we've chosen for the swap chain images in member variables. We'll need them in future chapters. There you go. I'm gonna actually make this a class. Also, I feel like we actually don't need to do it like this. Although this is more explicit, so I kind of prefer it. Also, this swap chain. Which you don't need to do it like that, but I want to do that. I'm not sure I like how I'm organizing this right now, but we'll leave it for now, honestly. I don't care too much about this. I'll worry about it later when I actually need to deal with encapsulation and stuff, but right now it doesn't matter. Okay. Cool. So there we go. And we have all this stuff set up. Awesome. And now we gotta do image views, and then you have all the graphics pipeline stuff, and then you finally can get to drawing. So there's so much code. Although this isn't too terrible. But I might do a lot of that stuff not streaming because it's just boring, honestly. It's just kind of boring stuff. I mean, programming is boring in general, but well, watching programming is pretty boring, I would say. But anyways. Okay, so we got a decent amount more done. We got the swap chain created after pain. This awesome issue. Anyways, I think I'm done for now. That was fun. Thank you for tuning into the stream. Those that did. Anyone that did. If anyone did. Going to go do something else. Yeah. Later.